What if I told you the future of the internet may not be built in massive buildings on land, but sealed on the ocean floor? Every time you stream a video, use cloud storage, or ask an AI question, you're using data centers. And data centers generate enormous heat every second, every day. Cooling that heat is expensive, energy-hungry, and one of the biggest limits of modern digital infrastructure. So engineers asked a radical question. What if we move data centers underwater, where the ocean itself can help cool them? At first, it sounds simple, but the engineering challenge is brutal. Challenge 1. Pressure. At depth, pressure constantly crushes against every surface. A tiny structural weakness can become a catastrophic failure. So the data center has to live inside a pressure-resistant vessel with near-perfect sealing, high-integrity welds, and materials designed for years of stress. Challenge 2. Corrosion. Salt water attacks metal, connectors, coatings, and exposed joints. If your protection fails, reliability fails. Engineers must combine marine-grade alloys, anti-corrosion coatings, and strict isolation of critical components. Challenge 3. Heat control. Yes, the ocean is cold, but cooling electronics is not just put it in water and done. Heat must leave servers in a stable, predictable way without creating thermal shock inside the system. Too hot, and hardware degrades. Too cold or unstable, and stress failures increase. So thermal design becomes a precision science, not a simple trick. Challenge 4. Maintenance. On land, technicians can replace failed hardware quickly. Underwater, emergency repair is expensive and slow. That means the system must be designed for long, autonomous operation. Fewer moving parts, smart diagnostics, predictive failure detection, and remote monitoring from day one. Challenge 5. Power and connectivity. An underwater data center still needs reliable electricity and high-bandwidth fiber links. Cables must survive currents, anchors, vibration, and long-term marine wear. One damaged connection can isolate an entire node. So why do this at all? Because if it works at scale, underwater data centers could reduce cooling costs, improve energy efficiency, and place compute capacity closer to major coastal populations. That could mean faster services, lower operating costs, and potentially a smaller environmental footprint per workload. In other words, the ocean is not replacing the internet. It may become part of how the internet survives its own growth. And here's the real question. Would you trust your photos, files, and AI data to a server sitting on the seabed? Comment yes or no. And subscribe for part 2, the hidden risks of underwater data centers nobody talks about.